Okay. Okay, you are welcome back to this VRC course. So this time around, I want to talk about the first component we'll be dealing with. In this section, we'll be dealing about all the components, and I'll be talking about resistor. That's what you are seeing there. Yeah, I mentioned about resistor, and this is how resistor looks like. That does two functions in a system. Resistor number one is used to oppose the flow of current. As light dey flow through, it limits them. And the way they normally use it, they use it to get a particular current rating to flow into a device. So you oppose the rest and allow that particular current rating you want to pass through that to that appliance, to that device, to pass through. So it opposes the flow of current. Another thing it does in a stabilizer board is that we use it to get a specific number of voltage. We use it to get a specific number of voltage. Now this meter, we are going to use one of the meter and use it to read it. We are going to show you how it reads on board and off board. On board is when the resistor is inside the board, and when the resistor is not inside the board is off board. So we will read it. We will show you how to read it with these meters so that you understand how to read it with this meter. Sorry for the video aspect, it's just only this video and that first video that had an audio issues. The rest, we ensure that audio issues are not there. Now, like I said, we use it to get a particular voltage, and that voltage line is called voltage divider system. What you see there, let's assume we have a 12 volts. With resistor, we can get a specific voltage from that. Now, this is called a voltage divider. 12 volts up, 0 volts down. Let's assume this resistor there is 10k. The second one is 10k. So meaning at the middle of both of them, at that middle, so you will get 6 volts. That's what resistor can do in the circuit. We put one resistor here, put one resistor here, so it breaks down the voltage and share it into two. And this is some of the function normally used in all these stabilizers. Now we have 6 volts, so you can even use that without using a voltage regulator to get a 6 volts from 12. The difference between that of a voltage regulator is that a voltage regulator is stable, but this one is not stable. It all depends on that 12 volts. If that 12 volts is stable, meaning the 6 volts you get there is stable. But majority of these things, designs you see inside this stabilizer, that's what they use in getting a particular breakdown voltage. All the old variable you see here, variable 1, 2, 3, 4, 5, they uses a voltage divider to function. That's why as you are winding it, it's either you are adding voltage to the IC or reducing voltage from the IC. That's another thing they do with that resistor. So number one is used to limit current flow. True, is used to get a particular voltage along that voltage line, and that is why they call it the system, a voltage divider. For those of you studying it in school, you might have heard of that, a voltage divider. That's it. So let me work with this auto range. This is a non-auto range meter, like I said before. This meter is a non-auto range because it had plenty stuff. Plenty stuff. And resistor is measured in ohms. So if you want to measure resistor, you look at the ohms range inside your meter. Look at it. And the symbol, they call it omega symbol. They call it omega symbol. You can see the omega symbol. That one you see there is current rating, but don't dare use it without this meter. It will blow the meter. Will not read current without this. I don't try it at all. May not go spoil my meter. I think you see how the plenty current rate 20 2 the milliamp, 200 milliamps, 20 amp, just like that. The next one you see is in ohms. They have 22k, 20k, 200k, 20m, 200m. The next one you see voltage line. The DC come first before the AC. And the next one you see there is capacitance. Mark you, I don't buy a meter without capacitance and frequency reading. Okay, you see that diode symbol for reading diode and for reading continuity. That yellow something. This yellow something you see here. So let me on it. Let me see how I could use it to read that resistance. This resistor you see there, I already know the value. It's 220k. But if you want to measure it with this meter, you have to look for the value that is above that resistor. I already know it's 220k, so I can't read it with 2k, I can't read it with 20k, I can't read it with even 200k. So I switch it at the range above the 220k, which is 2 meg. That's how they use this meter. If you senses you don't know the voltage, switch it. If you senses that what you are reading is high and you don't know, or is low, you don't know, switch it to the high range so that you can be taking it down. If it's out of range, you will not show effectively. You have to be winding it down until you get it. Just start using it, you will understand what I'm trying to say. So this resistor gave me 214, 215. That's the value of that resistor due to some practical issues. So don't mind them like that too. Because some materials they use in making this resistor, they send it to Nigeria. It's not the way you think. So that's why there's a short of resistance. $214 kilo ohms. So because of due to one or two stuff that happens to the material, and I don't know the language there, but at the end of the day, it did not read that 220. Although some of all this meter are not that accurate, but let me try it with this meter and let me see. Not that the other former meter is not accurate, but it still has some percentage. It's a cheap meter, so you can't use it to compare with this one like this. So this one, look at the range. Only one button doing the work of the diode, the continuity, and the resistance. Only one diode, only one for voltage, DC, AC, and current. And he also have that clamp. That's what I used to read amps. He also had NCV. I'm just doing a little briefing on this meter for you to understand how you use it to read it. So if I want to read it, I will switch it to that. Now this set you are seeing, so also this one, I think you see this one also. One button doing 3 functions. You see, it is this select button they're using selecting it. If you press it, I press the select button, it's in diode. Press it again, goes to continuity. Press it again, it comes back to ohms. This one, the same thing. You press the select, it goes to diode. Look at the diode showing by the side. Press it again, it goes to continuity. When you press it again, it goes to resistance. Diode, resistance. No, sorry, continuity. Then press it again, it goes to resistance. So Let me read it and see. Let me read it and see. 215, 215.5. You see the difference between this one and the other one. This one gives you 0.1 decimal. The other authority could not give you any decimal because he had a limit he can operate. And the limit it can operate is majorly 3.5 digits, not up to 4 like this ones. I'm reading the 220K on the board. These are 220K. Let's see what that one will give us. 210. It's still okay. So don't mind what you are seeing here also. It's good. That resistor is inside a board. So because it's connected to one or two circuitry, don't expect the exact value. But if you still get the exact value, not bad. But it's not ideal getting the exact value because I think you see this one, 217. It's still okay. $217. Only where you notice there is a problem is when it's reading beyond that value. Let's say it's 220, you now start reading 250 is bad now, or 1 meg. That one will affect the system. So what you do there, you just have to change it. But as it is now, those resistors are okay. So you can also repeat that. Get an old board, a condemned board, pick your meter, find out the value of that resistor, and when you have known it, read it with your meter. Now we have data sheets. You can check online for data sheet of resistor. We have resistor color code. You can check it online and get to know resistor color code and understand first band, second band, third band, fourth band, tolerance, and other stuff. We are not teaching you resistor color code here. So see you in the next video. The next video we'll be talking about other components. See you there.